welcome to the course. In this course, you will learn how to create stunning data visualizations using Plotly, a powerful open source library for data visualization in Python. In this course, we will be using Google Colab as our code editor, so you don't need to install anything on your local machine. We will create all visualizations from scratch and write the code together, so you can follow along easily. I won't be using any external data or slides in the course. Instead, I will create a simple dataset and use it to demonstrate various Plotly features. By the end of the course, you will have a solid understanding of Plotly's capabilities and be able to create complex visualizations on your own. Throughout the course, we will cover a wide range of topics, starting with basic line plots and moving on to scatter plots, bar charts, histograms, pie charts, and much more. We will also cover advanced topics such as 3D visualizations. Each module will be structured around a specific type of visualization, and I will explain the code as we go along, so you can understand the output. One of the major advantages of Plotly is its versatility. It provides a wide range of chart types, including line plots, scatter plots, bar charts, pie charts, heat maps, and even 3D visualizations. This means that regardless of the type of data you are working with, Plotly has got you covered. Plotly also offers an intuitive and easy-to-use syntax. Its syntax is very similar to other Python plotting libraries like Matplotlib, making it easier for users to transition between different libraries. With Plotly, you can create visually stunning visualizations with just a few lines of code. One of the key features of Plotly is its ability to create web-based visualizations. With Plotly, you can export your visualizations as HTML files or embed them directly in web applications. This makes it a great choice if you want to share your visualizations online or integrate them into interactive dashboards. In this course, we will be using Google Colab as our code editor. Google Colab is a free cloud-based Jupyter Notebook environment that provides us with the computing power we need without requiring any local installation. To get started, simply open your web browser and go to colab.research.google.com. If you have a Google account, sign in. If not, you can create one for free. Once you are signed in, you will be taken to the Colab home screen. From here, you can either create a new notebook or open an existing one. A new notebook will be created and you will see an empty code cell where we can start writing our Python code. We can write code in each cell and execute it by clicking the Run button or pressing Shift and Enter. Now we can move to the coding part. I will be at the Colab screen for the next parts of the video. Welcome to the coding part. We will start by installing and importing Plotly in Google Colab. Plotly is not included by default in the Colab environment, so we need to install it before we can start using it. To install Plotly, we can simply run the following command in the code cell. This command uses the exclamation mark to execute a shell command directly with the notebook. The pip command is a package installer for Python, and we are telling it to install Plotly package. Once the installation is complete, we can import Plotly into our notebook by adding the following line of code. Here we are importing the grab objects module from the Plotly library and aliasing it as Go to make it easier to work with. Now that we have Plotly installed and imported, we are ready to create our first visualization using Plotly. Now we will start by creating our first basic line. Line plots are one of the fundamental types of visualizations and are great for representing trends and patterns in data. To create a line plot in Plotly, we need two essential components, the x-axis values and corresponding y-axis values. The x-axis values represents the independent variable or the categories, while the y-axis represents the dependent variable or the values we want to plot. Let's start by creating some sample data for our line plot. In this example, let's consider we have a list of years as our x-axis values and a list of corresponding sales as our y-axis values. Now we can create a line plot using these data points. Seems nice. We created a good looking plot. In the code above, we imported the necessary plotly module as go. Then we create a figure object and specify the data we want to plot using the scatter trace. We provide the x-axis values as years and the y-axis values as sales. Finally, we call the show method on a figure to display the plot. This will open a new window or show the plot directly in the notebook. As you can see, the line plot is displayed and each data point is connected by a line. The x-axis represents the years and the y-axis represents the sales. You can hover over the data points to see their exact values, zoom in and out and interact with the line plot. Let's make a zoom operation here. As we can see, we can zoom to data like this. Now we will explore how to customize the plot layout, titles, and axes in our plotly visualizations. Customizing these elements allows us to provide context and improve the overall appearance of our plots. Let's continue working with the line plot we created in the previous section. We have our x-axis values stored in the years list and the corresponding y-axis values in the sales list. To customize the plot layout, we can modify various attributes of the figure object. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data using the scatter trace, just like before. Then we use the update layout method to customize various aspects of the plot. Here, we add a title to the plot using the title attribute, labels to the x-axis and y-axis using the x-axis title and y-axis title attributes respectively. Additionally, we hide the legend by setting the show legend attribute to false. As you can see, the plot now has a title at the top, labels for the x-axis and y-axis, and the legend is hidden. These modifications provide more information and improve the overall readability of the plot. Feel free to experiment with different titles, axis labels, and other layout attributes to further customize the appearance of your plots. Now we will explore how to add annotations and shapes to our Plotly visualizations to provide additional context and enhance the understanding of our data. Let's continue working with the line plot we created earlier. We have our x-axis values stored in the years list and the corresponding y-axis values in the sales list. To add annotations to our plot, we can use the add annotation method of the figure object. Annotations allows us to add text and arrow at specific locations in the plot. Let's write the code together and see how it affects the output. In the code above, we created a figure object and specified the data using the scatter trace. Just like before, then we used the add annotation method to add an annotation to the plot. You provide the x coordinate and y coordinate of the annotation, the text we want to display, and various other attributes like show arrow, arrowhead, ax, and ay to control the appearance of the annotation and the arrow. As you can see, the annotation higher salaries is added to the plot at the specified coordinates. The arrow indicates the location being referred to, adding clarity to the annotation. Apart from annotations, we can also add shapes to highlight specific regions or patterns in the plot. We can use the add shape method of the figure object to accomplish this. Let's write the code together and see how it affects the output. In the code above, we created a figure object and specified the data using the scatter trace. Then we use the add shape method to add a shape to the plot. You provide the type of shape, the x coordinates and y coordinates of the shape, the fill cover, opacity, and the line of width of the shape's border. As you can see, a yellow rectangle shape is added to the plot, highlighting the range of sales between the years 2019 and 2022. Now we will explore how to create scatter plots using Plotly. Scatter plots are a great way to visualize relationships between two numerical variables. To create a scatter plot, we need two sets of numerical data, one for the x-axis and another for the y-axis. Each data point represents a pair of values from these two sets. Scatter plots are especially useful for identifying patterns, trends, or correlations between variables. Let's start by creating some example data for our scatter plot. In this example, let's consider we have a list of students' ages as our x-axis values and their corresponding test scores as our y-axis values. And now we can create a scatter plot using these data points. Let's write the code together. In the Volleyball, we imported the necessary Plotly module as Go. Then we create a figure object and specify the data we want to plot using the scatter trace. We provide the age as x values and the score as y values. Additionally, we set mode to markers to display each data point as a marker. As you can see, the scatter plot is displayed and each data point is represented by a marker. The x-axis represents the age of the students and the y-axis represents their test scores. Scatter plots allows us to easily visualize the relationship between these two variables. Now we will explore how to customize markers, colors, and size in scatter plots using Plotly. Customizing these aspects allows us to add additional visual cues and highlight specific patterns or groups within our data. Let's continue working with the scatter plot we created earlier. We have our age stored in the age list and the corresponding scores in the scores list. To customize the markers in our scatter plot, we can modify various attributes of the scatter trace. Let's write the code together and see how it affects the output. In the codable, we create a figure object and specify the data we want to plot using the scatter trace. We provide the age as x values and the scores as y values. Additionally, we use the marker attribute to customize various aspects of the markers. Here we change the marker symbol to a star, the marker size to 10, the marker cover to red, and the marker border width to 2 and cover to black. As you can see, the markers in the scatter plot are now displayed as stars with a larger size, red color, and a thicker black border. These customizations help to distinguish the data points and add visual interest to the plot. Apart from symbols, size, and colors, you can also explore other marker customization options such as transparency, gradients, or even using custom images as markers. Feel free to experiment and make your scatter plots unique to your data. Now we will explore how to add error bars to our scatter plots using Plotly. These additional elements provide valuable insights into our data and help visualize trends and uncertainties. Let's continue working with the scatter plot we created earlier, which represents the relationship between age and scores. We have our age stored in the age list and the corresponding scores in the scores list. Error bars provide a visual representation of the variability or confidence intervals around each data point. Let's write the code together to add error bars. In the code above, we create a figure object and specify the data we want to plot using the scatter trace. We provide the age as x values and the scores as y values. Additionally, we customize the markers by setting the color attribute to blue. To add error bars, we use the update trace method and set the error y attribute to a dictionary containing the type of error bar and array of error values for the y-axis, and make the error bars visible by setting visible equal to true. Now we will explore how to create bubble charts using Plotly. To create a bubble chart, we need three sets of numerical data, one for the x-axis, one for the y-axis, and another for the marker size. Each data point represents a set of values from these three sets. Bubble charts are particularly useful when we want to visualize relationships between multiple variables and represent a third variable through the size of the markers. Let's dive into an example. Consider we have a dataset containing information about cities. For each city, we have the population, the average temperature, and the GDP. We can create a bubble chart to represent the population and average temperature on the x-axis and y-axis respectively, and use the marker size to represent the GDP. Let's start by creating some sample data for our bubble chart. In this example, let's consider we have three cities. Now let's write the code together to create the bubble chart. In the code above, we create a figure object and specify the data we want to plot using the scatter trace. We provide the temperature as x values and the population as y values. Additionally, we use the marker attribute to customize the marker size, its scaling mode, the reference size, the minimum size, the marker color, and show the color scale. We also provide the city names as text to display as tooltips when hovering over the markers. As you can see, the bubble chart is displayed, with each city represented by a marker. The x-axis represents the average temperature, the y-axis represents the population, and the marker size represents the GDP. The larger the marker size, the higher the GDP value for each city. Bubble charts allow us to visualize multiple dimensions of data in a single plot, making it easier to identify patterns and relationships. We can explore various combinations of variables and marker sizes to gain insights into our data. Now we will explore how to create vertical and horizontal bar charts using Plotly. Bar charts are useful for visualizing categorical data and comparing values across different categories. Let's start by creating a simple vertical bar chart to represent the sales performance of different products. We have a list of product names stored in the products list and their corresponding sales values in the sales list. To create a vertical bar chart, we can use the bar trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the bar trace. We provide the product names as x values and the sales values as y values. As you can see, a vertical bar chart is displayed, with each product represented by a bar. The height of each bar represents the corresponding sales value. The x-axis represents the product names and the y-axis represents the sales values. We can also create a horizontal bar charts by simply switching the X and Y values. Let's modify the code to create a horizontal bar chart instead. In the code above, we create a figure object and specify the data using the bar trace. We provide the product names as Y values and the sales values as X values. Additionally, we set the orientation attribute to age to create a horizontal bar chart. As you can see, a horizontal bar chart is displayed with each product represented by a bar. The length of each bar represents the corresponding sales value. The y-axis represents the product names and the x-axis represents the sales values. Bar charts are versatile and can be customized in various ways. You can modify the colors, add labels, tooltips, or even stack multiple bars to represent additional dimensions of data. Now we will explore how to create grouped and stacked bar charts using Plotly. Grouped and stacked bar charts are useful when we want to compare values across multiple categories and visualize the composition of each category. Let's start by creating a grouped bar chart to compare the sales performance of different products across different months. We have a list of months stored in the months list, a list of product names stored in the products list, and a two-dimensional list of sales data stored in the sales list. To create a grouped bar chart, we can use multiple bar traces provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and iterate over each product using a for loop. Inside the loop, we use the bar trace to create a bar chart for each product. We provide the months as X values, the sales data for each product as Y values, and set the name attribute to the product name for labeling purposes. Now we will explore how to create histograms using Plotly. Histograms are useful for visualizing the distribution of numerical data and analyzing its frequency or density. Let's start by creating a histogram to analyze the distribution of exam scores for a class. We have a list of exam scores stored in a scores list. To create a histogram, we can use histogram trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the histogram trace. We provide the exam scores as x values. As you can see, a histogram is displayed representing the distribution of exam scores. The x-axis represents the range of scores and the y-axis represents the frequency or count of scores falling within each range. Each bar in the histogram represents a bin, which is range of scores. Histograms allows us to make visual the shape of the data distribution, identify any patterns or outliers, and gain insights into the data. We can modify the number of bins to adjust the level of detail and granularity in the histogram. We can also customize the appearance of the histogram by adding labels, adjusting the colors, or changing the layout. Now we will explore how to create pie charts using Plotly. Pie charts are useful for visualizing proportions and percentages of different categories within a dataset. Let's start by creating a pie chart to represent the distribution of sales across different product categories. We have a list of product categories stored in the categories list and their corresponding sales percentages stored in the sales percentages list. To create a pie chart, we can use the pie trace provided by Plotly. Let's write the code together and see how it affects the output. There was a wrong display there since we didn't set the fig. Now it's okay. In the code above, we create a figure object and specify the data we want to plot using the pie trace. We provide the categories as labels and the sales percentages as values. As you can see, a pie chart is displayed representing the distribution of sales across different product categories. Each category is represented by a slice of the pie, and the size of each slice represents the proportion of sales within that category. Pie charts are effective in displaying relative proportions and making comparisons between categories. They provide a visual representation of the distribution and help in identifying the dominant or least significant categories within a dataset. We can further customize the appearance of the pie chart by adding labels, adjusting colors, or highlighting specific slices using the hover info attribute. Now we will explore how to customize slices, labels, and annotations in pie charts using Plotly. These customization options allows us to enhance the visual representation and make our pie charts more informative. Let's start by customizing the slices of a pie chart to highlight specific categories. We have a list of product categories stored in the categories list and the corresponding sales percentages stored in the sales percentages list. To customize the slices, we can use the marker attribute within the pie trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the pie trace. We provide the categories as labels and the sales percentages as values. Additionally, we customize the color of each slice by setting the colors attribute within the marker dictionary. As you can see, the pie chart is displayed with the custom colored slices. Each category is represented by a slice, and the color of each slice is determined by the specified colors in the colors list. This customization makes it easier to differentiate between categories and adds visual appeal to the chart. We can also customize the labels of the pie chart to display additional information. Let's update the code to include custom labels. In the code above, we create a labels list by combining the category names and sales percentages using a list comparison. We update the labels attribute of the pie trace to include the custom labels. As you can see, the pie chart is displayed with custom labels for each slice. The labels provide additional information by showing both the category name and the corresponding sales percentage. Now we will explore how to create sunburst charts using Plotly. Sunburst charts are useful for visualizing hierarchical data and displaying proportions at different levels of hierarchy. Let's start by creating a sunburst chart to visualize the sales breakdown of different product categories and subcategories. We have a nested dictionary sales data that represents the hierarchical structure and sales percentages of the categories and the subcategories. To create a sunburst chart, we can use the sunburst trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the Sunburst trace. We provide the labels, parents, and values for each segment of the Sunburst chart. As you can see, a Sunburst chart is displayed representing the hierarchical structure and sales percentages of the different categories and subcategories. Each segment of the Sunburst chart represents a category or subcategory, and the size of each segment corresponds to the sales percentage. Sunburst charts allows us to explore the proportions at different levels of a hierarchy and identify the contributions of each category or subcategory to the overall sales. We can further customize the appearance of the Sunburst chart by adjusting the colors, adding labels, or changing the layout. Now we will explore how to create box plots using Plotly. Box plots, also known as box and whisker plots, are useful for visualizing the distribution statistics of a dataset and identifying outliers. Let's start by creating a box plot to analyze the distribution of values in different categories. We have a list of categories stored in the categories list and corresponding datasets stored in the data list. To create a box plot, we can use the box trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and loop through each category and dataset. For each category, we create a box trace and provide the dataset as the Y attribute and the category name as the name attribute. As you can see, a box plot is displayed for each category, representing the distribution of values within each dataset. Each box plot includes several components: a box that represents the interquartile range, a line within the box that represents the median, and whiskers that extend to minimum and maximum non-outlier values. Box plots allows us to quickly analyze the distribution statistics of a dataset, including the median, quartiles, and potential outliers. They are particularly useful for comparing the distribution of values between different categories and identifying any variations or anomalies. By the way, I need to add that we displayed three graphs, and at the lower side we can see our three of our categories together, like this. Now we will explore how to create heat maps using Plotly. Heat maps are useful for representing data matrices and visualizing the magnitude of values using colors. Let's start by creating a heat map represent a data matrix. We have a two-dimensional list data matrix that represents the values in each cell of the matrix. To create a heat map, we can use the heat map trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the heatmap trace. We provide the data matrix as the z attribute. You can see a heat map is displayed, representing the values in each cell of the data matrix. The colors in the heat map correspond to the magnitude of the values, with higher values shown in darker colors and lower values shown in lighter colors. Heat maps are particularly useful for identifying patterns and trends in large datasets. They allow us to easily spot clusters, outliers, and variations in the data. We can further customize the appearance of the heat map by adjusting the color scale, adding labels, or changing the layout. Now we will explore how to customize color scales and add annotations to our heat maps using Plotly. These customization options allows us to enhance the visual representation and provide additional information to our viewers. Let's start by customizing the color scale of our heat map. By default, Plotly uses the weirdest color scale, but we can choose from a wide range of predefined color scales or create our own. To customize the color scale, we can use the color attribute of the heatmap trace. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the heatmap trace. We provide the data matrix as the z attribute and the color scale attribute to blues to use a different color scale. As you can see, the heat map now uses the blues color scale, where lighter colors represent the smaller values and darker colors represent larger values. Choosing the right color scale can significantly impact the perception of the data and highlight important patterns or trends. Now we will explore how to create three-dimension scatter plots and surface plots using Plotly. These visualizations are particularly useful for representing data with three dimensions. Let's start by creating a 3D scatter plot. We will use the scatter 3D trace provided by Plotly to create the plot. Let's write the code together and see how it affects the output. In the code above, we define three lists x, y, and z to represent the coordinates of the data points in the three dimensions. Next, we create a figure object and specify the data we want to plot using the scatter 3D trace. We provide the x, y, and z attributes to define the positions of the data points. The mode is set to markers to indicate that we want to create a scatter plot. We also customize the marker size and color using the marker attribute. As you can see, a three-dimensional scatter plot is displayed where each data point is represented as a marker in three-dimensional space. The size and color of the markers can be customized to convey additional information about the data points. Now we will explore how to customize axes, grids, and lighting in our 3D plots using Plotly. These customization options allows us to enhance the visual representation and provide a better understanding of the data. Let's start by customizing the axes of our 3D plot. We can modify the range, labels, and tick values of the axes to better represent our data. Let's write the code together and see how it affects the output. Also, I'm going to use the upper code here. I copied it and I will paste it. It's the same code. I'm not changing anything, but I'm going to edit and modify it. I'm sorry for the typo there. I can cut this, but I'm not going to cut it because I also want to show you that how I fixed the code. We were missing x-axis here and we didn't close a parenthesis and we both did, and after that our code works nicely. As you can see now we have a three-dimensional visualization. In the codable, we define three lists x, y, and z to represent the coordinates of the data points in the three dimensions. Next, we create a figure object and specify the data we want to plot using the scatter 3D trace. We provide the x, y, and z attributes to define the positions of the data points. The mode is set to markers to indicate that we want to create a scatter plot. We also customize the marker size and color using the marker attribute. To customize the axis, we use the update layout method of the figure object. Within the scene attribute, we customize each axis individually by providing a dictionary with the desired modifications. We can specify the title, range, tick mode, tick 0, and dtick to control the appearance of the axis. As you can see, the axes of the 3D plot are customized with new labels, range, and tick values. These modifications allows us to provide more meaningful information about the data and adjust the scales according to our needs. That was all for the Plotly course. Thanks for watching this course. I hope you found the course helpful and informative. We covered a lot of graph types and applied them one by one. I will keep uploading this type of courses. Have a great day.